and there my microphone is live, so that's good. If you haven't gotten the chance to enjoy the demo yet, feel free to do that. It's a bit funny actually that even though I try to make like a very contained experience where you can't do anything wrong, then you still find some way to inject some questionable stuff. So I got some nice photos now. It's probably a good blog post. But yeah, it's fun. And some of you even found a way to put text in. I'm not actually surprised because this is a very simple app with basically no input validation. So yeah, it's probably a lot worse stuff that you can do. So I guess I'm asking for trouble. But super fun. I think we should probably continue on before more risky stuff happens. So anyway, good morning, everyone, and thanks for coming to my talk. I'm going to talk a bit about real-time experiences, or I guess more the technology behind real-time connections on the web. And the app that you just saw that you got to play around with is kind of what we'll use as the basis for this, and talk a bit about how it works. Because what I feel like whenever we talk about these kinds of real-time applications, everyone kind of thinks that they're super advanced, that you need some kind of magic frameworks that inject a ton of code to make this happen. But the truth is that you can actually build something like this very easily, and that's what we're going to look at. And just to be super clear, when I say real-time connection, what I mean is some kind of application that sends or receives data in real time. So as soon as you send the data, something is supposed to happen. Either you receive data from someone else, say a chat message or something like that, or you use the data to control something else, and the goal is to reduce the latency. So the app that you just got to play around with uses something called EventSource, and it's actually just about 20 lines of JavaScript, both on the server and on the client, and of course some CSS in there to make it look pretty. But it doesn't have to be more advanced than that. It doesn't use any JavaScript frameworks other than a simple HTTP server. It uses this interface called EventSource. And the server simply sends back a very specific HTTP response and keeps the connection open. And we're going to get back to more how this works. But what's funny is that I just discovered this way of doing it in relation to some kind of interview assignment I used or I went through a couple of years ago. And I was surprised that this is super simple, but why is nobody talking about it? I feel like as soon as you mention real-time, everyone's straight onto the WebSocket verb. Everything has to be WebSocket, and I get it. WebSockets are super cool, and just the way that they work gives you a lot of cool opportunities that you can make. You can make your own protocols. You can basically do anything, but for a lot of cases, it might be overkill. And especially for prototyping purposes, for hackathons, and just if you want to transmit data one way. So what I want to talk about today is I had two goals when I set out to write this talk. The first one was to tell more people about SSE, also known as EventSource, or also known as server-sent events or event streaming. And the second one was to figure out why nobody talks about it. And my name is Benedicte. I sing in a choir. I have two big dogs back on the family farm. I do a lot of gaming, both new and old. And about 2 years ago, I started this company that specializes in consulting or contracting work in tech, where we specialize in getting people that are kind of the bridge between technology and communication and culture, because those are things that I burn for. So today we're going to talk about some techniques, some technologies that basically fall into 3 different categories. But what we're going to talk about is very heavily based on the web, so I feel like the place that we should start is the foundation of web. And everyone, of course, know that that's HTTP. HTTP is the way your browser downloads stuff. It can download more or less anything at this point. In the beginning, it was a bit more limited. but it powers so much of our day-to-day. And I feel that we talk so little about it as web developers. I feel like if you're at an SRE or you work with ops, then you talk a lot more about HTTP. But if you make applications for it, I believe that if you know some of the details behind it, know some things about versioning and what kind of features you have available, kind of the pros and cons of newer and old versions, then you can make better applications. So let's just start at the beginning. This and the guy in the middle there is Tim Berners-Lee. He used to work at CERN, and in 1981 he kind of invented the internet. And what he gave us this first time around is HTTP and a simple HTML and the URI and some other stuff. And this first version of HTTP is what we later called HTTP 0.9. And this is all that there is. So there's a request and a response. You only had the GET method, for example, and you gave it a path to some kind of document. The document had to be HTML. And you get that HTML back. Of course, after this kind of took off, there were no standards being enforced or anything. So back in the old days, everyone kind of jumped on this because it was getting more popular, and they made their own features on top of this. And it turned into a lovely chaos that I'm sure a lot of you have been working in at some point. But thankfully, the HTTP working group was established in 1996, and they kind of did the work to go out in the industry and try to discover how people were doing this and actually document it. And what they came up with in 1996 was this HTTP 1.0. And here you see that we have some more features already. We have headers, for example, which was new. We actually have a versioning scheme right now. We have response codes and reasons, and we have content types. And you see also in the response there, we have linked a file with a different format because this was the first time that HTTP actually let you download other things than actual text. Well, in a standardized manner, I guess. But from there, the next year, in 1997, the HTTP working group came together and made HTTP 1.1, which actually was the first standardized version. And it brought with it a lot of new features, like persistent and pipelined connections, virtual hosting, those kind of stuff that are under the hood. But you also got stuff like content negotiation, meaning that the browser could finally tell the server something about what kind of content it wanted, and then you could return that. You also got caching and a lot more methods like put, delete, trace, and options. And this is what the response looks like now. We have content type that tells something about what you're getting back. We have some encoding. We have a lot of juicy stuff. Also one that's called transfer encoding chunked, which will become relevant later in this talk. So during this time, there was the big browser war between a Netscape Navigator and Internet Explorer. And this was 1995 to 2001. And in 1995, these are the founders of Netscape, by the way, and they hired this guy called Brendan Eich in 1995. And they tasked him with creating some kind of scripting language for their browser because they wanted interactivity. He did that and made a simple version based on Lisp, and it couldn't really do that much at that point. It could basically just validate forms before sending them. But from there, some very smart people at Microsoft made something called XHR, or XML HTTP request, which was the first time you could actually send requests in the browser in the background. So this was initially called ActiveX, and I'm sure a lot of you have seen that before. And the idea was to kind of separate the request and the response from the actual loading of the document that happens in the browser so that you can do updates in the background. The next thing that we got was this thing right here that's called the DOM, and I'm sure a lot of you have seen it. It's the Document Object Model, and this let you use the scripting language that Brenda and I came up with to kind of modify the document that the browser is currently viewing, allowing for creating interactivity. The DOM as well, in the beginning, it only lets you work on forms and tooltips and that kind of stuff, but it became more advanced after a while, and these days you could do basically anything with this. But based on these technologies, this guy called Jesse James Garrett, he coined the term AJAX, and AJAX stands for Asynchronous JavaScript and XML. And it was kind of a word to define how you would go from not only creating web pages, but also creating interactive applications by using HTML, the DOM, some kind of formatted data like XML or JSON, XHR, the XML HTTP request that we saw, and JavaScript. And now, at this point in history, we kind of have all our ingredients to look at the first technique. And the first technique is called polling, the first technique to create real-time applications. And polling works, I'm sure a lot of you have seen it before. It works by asking for data again and again and again until you get more data. And maybe not that efficient. You have a lot of waiting. In this kind of case, you do a lot of unnecessary requests. But it was normal at the time, and this was how that you could do it. You made a function, you used the XHR to send a request, and you did that again in a certain amount of time. So by adjusting the frequency of how often you ran, you could get the latency or the time until you get new data to be shorter, but at the same time you would put more strain on your server. So to summarize, the polling technique, it requires nothing special from your server. And the client implementation is super simple. Everyone knows how to make a loop. Scalability is a bit poor because you put so much strain on your server. Imagine you have 1,000 active users or more, and they're all kind of pushing and making requests to your server all the time. It's a good way to kind of DOS yourself. The data direction at this point is one way, so you get data from the server to the client, and the latency has the potential to be big, and that kind of sums up a polling for us. So this worked, and a lot of services at the time was using this, but it was not kind of good enough, so people wanted a better way to do things. And this led to the word a comet, which is Alex Russell's attempt at kind of making a name for this new movement. And he said that an old web technology is slowly being resurrected from the depths of history. Browser features that have gone untouched for years are once again being employed to bring better responsiveness to UI. So it's a bit interesting that you actually go to the past to find technologies to do this thing. And this is a picture of him, by the way. He's also the owner of the Blink API, which powers a lot of browsers. And this also brings us to the next technique that you could use to implement real-time. And it's a bit more interesting than polling, I guess, but it has a lot of similarities, which is why it's called long polling. So what you do in long polling is that you send the same request as you would do for a polling implementation to get data. But what you get from the server is basically this. So the server will keep you there and say nothing for a while, and then something happens and you get some data. And by doing this, you basically get some kind of interactive queue that the client doesn't have to care about. And as soon as the data that you're interested is available, the server will give it to you, and thereby eliminating the latency, but without requiring that much more from the client. And so that means that the client implementation is exactly the same. We just rename the function, because you still want to make the request again, because the server won't tell you anything more than what it has at that exact point. So you continue, and the server implementation could look like this. You get some kind of ask for data, a get request. You put the connection somewhere you have access to it, but you don't do anything specific with it, and you make sure to not close it. But then in the post controller, for example, where you receive data, whenever you receive data, you loop through your array, you write that data out to all the pending requests, and then you close them at the same time, and you reset your queue. So it's a very naive example. If you use this, clients that are in the middle of reconnecting, for example, they won't get messages. So it's not a very robust example, but you could easily go around this if you wanted. So to summarize a long polling, the basic difference here is that you keep the connection open from the server, and then the client doesn't have to change anything. The scalability is a lot better because you don't have to do all those extra requests. You still poll, but you poll a lot less. The direction for data here is still one way. You can only send data from the server to the client. And the latency is basically gone, but for a bit less data. If you have a lot of data, then this becomes kind of a big problem, especially where you are in the reconnecting step. So the session is still stateless. That means that that the server won't know you're the same person the next time you connect, because they are all actually separate requests under the hood. And now all of a sudden you have this small infrastructure requirement that you have to keep the connection open, and especially in complex HTTP setups where you have a lot of ingresses and maybe proxies of some sort. A lot of those services have a lot of opinions about how long HTTP connections are supposed to live. So that's kind of thing you should check if you're going to do this. But at this point, everyone were kind of still, okay, we have a good real-time technique right now, but everything is kind of based on hacks upon HTTP, and to use HTTP in ways it was not meant to be used. So this is what kind of inspired Ian Hickson and Michael Carter in the HTTP working group to start making ideas for how to improve this. And what's interesting is that they did all this discussion on IRC, which is an open platform. So you can actually find the IRC logs from when they actually discussed how the WebSocket was supposed to look and be shaped. And that's very interesting, at least to me. So that brings us on to the WebSocket, and at this point we switch the protocol, because the WebSocket is completely different from HTTP, and that is by design. You still send, oh, my monitor screen just gave up. It's back, no worries. You still send a GET request, because the WebSocket is designed to be backwards compatible with HTTP, because all the browsers are very good at HTTP. So you send a GET request, but you specify a couple of extra headers, like upgrade WebSocket and connection upgrade. And this is supposed to tell the server you're talking to that, hey, I want to actually switch protocol over to talk WebSocket instead. And you also have some different headers that you can supply, the sec WebSocket key and the protocol and version. And they are kind of tools for the server to do WebSockets in a different way. You can use the protocol to kind of choose between channels. That's at least how far I've understood it. And the WebSocket key is kind of an attempt at doing a cryptographic key verification kind of thing. I read the RFC on that, and it's basically concatenating some kind of hard-coded string. So I didn't quite get it. But if you want to look up more into that, go to the RFC. It's very interesting and it's very well written. So what you get back if the handshake part works out fine is this response right here. So you get a normal HTTP response. It echoes some headers back to you, upgrade and connection upgrade. And then it says accept, and then it returns a value to you, which is the concatenated string for the cryptography thing. And then you get some information about which of the sub-channels that you wanted that you got, which is chat in this example. And from this point on, what the two partners are communicating with is no longer HTTP. This is now a low-level binary format, and it runs on top of TCP, which is kind of the lower level in the networking stack. You can say that WebSocket is kind of on the same level as HTTP in the model of the internet. And I kind of feel like I want to talk about how the internet works, but I think that's going to be a different talk because you have so many levels. But at this point, you start exchanging frames, which are binary made up of a certain format where you have bits signifying what kind of packet it is, and then you have data in it that has to be split over frames, and it's a whole thing. But it works very well. So from the client, all browsers now have good support for using WebSockets. You point it to a WebSocket URL, which is WSS is kind of the protocol that they chose. That's the encrypted one. WS is the unencrypted one. And you say which protocol or sub-channel that you wanted. And from there on, you can attach events to it. So you tell the browser that whenever you receive this kind of event, do this. And you don't have to worry about the binary format and everything. That's more of a, if you wanted to implement this from the bottom up. On the server, however, this is not always that straightforward. It depends a lot on the framework that you're using to do HTTP. Because the thing is that HTTP is one framework and is one protocol, but WebSocket is a completely different one. So you have to support that one as well. And if you want to run the WebSocket server on the same server that returns your HTTP, then you have to make sure that they talk together, because the handshake part will still happen in HTTP. So if you wanted to do this in Express, for example, which is a very commonly used JavaScript framework, you have to use a different package called ExpressWS, unless you want to implement it yourself. Then you get some nice ws.on listeners and syntactic sugar that kind of looks like Express. But what we see if we dive a bit further into this and how the ExpressWS framework actually works, it uses a different framework again, WS, which is a very pure implementation of WebSocket for JavaScript, which is a very good library, so it does a lot of stuff, but you still have to work on making sure that your HTTP and your WebSocket is integrated. So to summarize WebSockets, WebSockets are a completely different thing. You have a handshake part, and then you have the protocol, the communication itself. The handshake tells the browser to switch its protocol over to talking, so you go from HTTP to a different language, and then you have this custom data format. That is what you transmit. The client implementation when using WebSockets is very simple. Scalability is very good because you open one connection and you can transfer data both ways, which is the big improvement here. All the other channels that we talked about, you could only get data from the server to your client unless you started requests in the background. But in the WebSocket, you can send everything. So it kind of looks a bit like how desktop applications used to be. And that's also a bit interesting because before doing this on the web and in the days when the web was very simple, you did these kinds of things in desktop applications instead because it gave you better control over stuff like this. And it's also why I think if you go to a job that has some sort of legacy software and it's a desktop application, it's a well-defined for the time, I think. So it's a thing you'll often find. But at this point, the latency is basically none. The session now, all of a sudden, is stateful. It means that if you've opened this connection, if you've opened this tunnel, then the server can actually be somewhat sure that that is the same person I'm talking to, and it kind of can store data along the way. But it also opens up a bit of requirements for your infrastructure, because now you not only have to support HTTP, you have to make sure that this more generic TCP also works in all the chains in your setup. And I'm sure that for a lot of cases it will work out of the box, but I also think that it's a thing to test. And my point is that when you have WebSockets and you have HTTP, then you have two different things. You have two quite complex components that need to work together. So it puts a bit of requirements on you. It's, of course, isn't impossible or anything like that. It's very easy to do with modern frameworks, but it's something else to consider. We see that there's a gap here in this table. And it kind of feels like there should be something that's simpler to use, but gives you a lot of the same things. And this is where server-sent event comes in. Let's try to just keep it simple. So let me show you what server-sent events are. You start out with the same GET request, where you ask for some data. You specify a couple of... no, wait, the client doesn't have to specify anything, actually. But when you get to the response, this is what it'll look like. You'll get a 200. It will say a couple of special headers called content type text event stream. And it'll also say, I have to search for them now because I've forgotten. OK, but that's the most important one. For older versions of HTTP, the transfer encoding chunked was also very important because it gave HTTP the opportunity to not just give you everything at once. You could give it in chunks. But in HTTP2, this works a lot different. But what happens is you get the headers first. It tells you event stream. It tells you to keep the connection open. And then you wait for a while. Something happens on the server. And you get this piece of text. It says ID is something, and it says event is something else, and then it gives you some data. But then the connection is still open, the server isn't finished yet, but it will keep you there for a while until something else happens, and then you get another event, separated by 2 line breaks. It has another ID, it might have a different event name, it might have some other data. And this is the basis of how an event stream or server-sent events work. You need some kind of way to parse this in the browser. You could write it directly by using fetch or XML HTTP request, but the browser gives us a nice interface to do it for us. So you say new event source, and you give it the URL, and then you can register listeners. So every time one of those events come in, you can get something to happen. And on the server side, this is what the implementation looks like. You still have that same list of connections from the long polling example. And the first thing you have to do is, when a request comes in, is to return the status to 200 and these specific headers. So the content type, the cache control, and the connection keep alive. And after that, you have an HTTP tunnel that in practice looks a lot like a WebSocket, but is only one way. And there you can write data on that format, and you have native support for parsing that in the browser, which is pretty cool, is what I think at least. So to summarize, server-sent events, you keep the connection open, you use a specific format. The client implementation is super simple, just as simple as the WebSocket. The scalability is actually very good, because in HTTP 1.1, you had to use this special transfer encoding chunk thing, and there were some requirements on how many open connections you could have towards a server at a given time. But all of those were fixed in HTTP 2, and that kind of means that the overhead by doing it this way and overcoming the fact that you could only send data from the server to the client by doing requests in the background, normal HTTP requests. In practice, it would be more or less as efficient as using WebSockets because of the way HTTP 2 works under the hood. But only this time, you didn't have to worry about any sort of extra server implementation or extra protocol or switching over to it or anything like that. You'd get all of this quite amazing functionality just out of the box. So yeah, the direction is still one way, but a short mindset change could kind of do that for us. The session now is stateful as well. If you have one of those streams open, you are sure that it's the same client that you're talking to. And you have the same infrastructure requirements as the long polling example. You have to keep the connection open, but this time it's just normal HTTP. And that's kind of our introduction into all of these technologies. So just a note about security, if we have time. So the WebSocket doesn't do authentication in itself. you can use those security headers or stuff like that, but you have to implement some kind of verification yourself. There's a lot of ways to do that. You could have some kind of endpoint first that returns a unique URL with dynamic URLs for each client, so that there's some kind of UUID in there. And another interesting thing is that the EventSource interface in the browser, it doesn't let you specify any headers. So it will also always be a normal GET request. So you can use stuff like cookies, but you can't specify JWTs in header, for example. So that's a bit of an interesting limitation that I want to learn more about, is what I feel. So at this point, going back to the app that we saw in the beginning, and I'm pretty sure I lost internet right now, so if you wanted to do more destructive damage, then we're going to have to do that next time. But this app that you just saw, what it did was it allowed you to send emojis to a server, and those emojis were being sent back to all the clients that were connected, and they were also being displayed on screen. And the implementation is this. This is the server implementation, so it has a GET endpoint that lets you subscribe to the events, where I do exactly the same as for the introduction to event stream. I write the headers, I write the status code, and I flush them. I put the client in a list, and then every time you want to send a message, every time someone else sends a message, you just loop through that array of connections, and you construct one of these ID event data containers to send. And the interesting thing is that since you have the event name, you can send arbitrary events this way. You don't have to send only one type. And because of the way the EventSource interface works in the browser, you can specify the name of the event when you add an event listener, and you'll get out of the box custom functions for each type of event. So the chat application, it has 3 different kinds of events. It has a ping event just to keep the clients connected, and it has a new message event whenever a new message comes in, and it has a new person connected event, so that every time someone connects, it can update the counter at the top. So yeah, and other than that, it uses the document object model directly just to add a new div whenever something happens. So no frameworks at all. And when it comes to what you can use real-time stuff for, and this is kind of my whole idea, is that if you can make this simpler, if it's easier to implement real-time stuff, that means there's basically no limit to what you can do. So I don't know how many of you do host Eurovision parties, but they're usually a big hit at my house, and we do them every year. And we also have our own custom voting app. But the thing with Eurovision is that there are a lot of songs every show. So you kind of want this to move quickly, but you don't want your guests to be on the phone their whole time. So with EventSource and with this event stream, I made a way to go to the next song from my phone, and then whenever someone else opened their phone, the page would be switched for them automatically without using a native app, just with a normal browser. So it kind of shows that you don't necessarily need to use real-time communication to transmit a lot of data, but you can use it to give to make it feeling instantaneous and make it feel a bit of a different experience, because it's always cool when things kind of happen just by themselves and when someone else does things. So that was a bit about how all of this works, but I thought it could be interesting to kind of dive a bit into a lot of the commonly used frameworks for doing real-time and kind of look into what they actually do under the hood, because this is what I find so interesting about learning how a protocol actually works, is seeing how we use it from day to day, because most people don't implement this from the ground up. So this is a library called Socket.io, and they put all of their inner workings in a different library called Engine.io, which kind of does the heavy lifting. And here we can see that it will try to upgrade the connection that you're currently using. So if you use Socket.io, you can kind of give it, you need a Socket.io server and you need a Socket.io client, and you point it there, and it will kind of try out to see how far it can upgrade you. It will start with something simple like polling or long polling, and then it will see, are you able to run event stream in your infrastructure setup? Are you able to run WebSockets? And then it will upgrade you. And the transports directory is collapsed right there, but if you open it, you can see a different file for each technique that we've been through. And if we continue a bit, this was actually in relation to someone I spoke to earlier at this conference, and they were using Firebase. And they were like, yeah, we're using Firebase WebSockets. And I'm like, that is interesting. How does that work? So I tried to figure out how that works, and the internet was very quiet about how this works. I think some kind of Firebase employee went and said that this is proprietary. We don't share this. But you can look at this Java framework. This is actually JavaScript, and to get an idea of how it works. And there we see that it actually has a relationship to different kind of real-time protocols. It will try WebSocket first, it kind of looks like, and then it will try moving over to long polling. And I'm sure since WebSocket is such a pure implementation, it's only like a step above TCP, so you can send anything, then they probably made their own format on top of this, which runs over this tunnel. So that's pretty cool. The next one, since this is a .NET conference, of course we have to look at some .NET. This is SignalR, and I think I was at a talk yesterday where someone was using SignalR. Oh, it was a robot arm. If you haven't seen that one yet, you should go see it on YouTube when it comes out. That was super cool. So a SignalR is kind of like Socket.io. It's a framework for doing real time, but making it a bit more technique agnostic. And we see it kind of looks like it's doing the same thing as Socket.io. I was really searching to find the kind of upgrade mentality, but I couldn't find it. So I guess I have to look more deeper next time. But we can see that it has implementation files for all of the different techniques, and at this point, SSE, for example. So I'm sure that if you use SignalR and your infrastructure doesn't support WebSocket, then SignalR also will fall back to that technique, which is also cool. And here you see they've actually implemented their own way to parse this text that we just saw, where you see data colon and trim, so which is pretty cool. Always cool to see how the things that actually happen further down in the stack actually, that we use them, and often without thinking about it. So yeah, and I think we're nearing the end for me. I used a lot of resources when building this, and I looked a lot into the history. And this blog post from websocket.org was very helpful, but didn't really give me insight into why nobody's talking about this. I feel like it maybe be because we have so many cool frameworks now that lets us do all these kinds of real-time stuff under the hood and choose the best protocol that there is. But I still think that having a relationship to what actually happens will make you a better developer, because then you could spend shorter time in implementing the real-time if you only use event stream, or if you know that you have an HTTP setup, then you know that you can jump straight onto event stream. Or if you do transmit a lot of data up, then you know that WebSocket is probably what you need. And I know one of the stands at the show floor actually has this game that you can control from your phone, and I'm pretty sure that they use WebSocket because that moved very quickly. So that was very cool. Go try that game. A lot of resources I used came from this company, so I kind of felt like I had to do a shout out to them. I think they make some kind of real-time server thing, so go check them out. They produce a lot of good articles. And I think now we're getting near to the end. And if there are any questions, please feel free to come with them. And I'm going to see if, because I mean, this is Norway, so nobody wants to ask questions. But if I can get this to refresh, then maybe we have Slido. And I still think we're doing a bit good on time, so we have some time for questions. And if anyone raises their hands, I'll try to see you. Oh, there's a question.
It's not a question, it's a comment. I say it's not a question, it's a comment.
Yeah?
You said Berners-Lee was father of internet.
Yeah?
I think that's a little disrespect for the other people because he's inventor of web, not internet.
Yes, that is a very good point. So what you said was it was a bit disrespectful to other people to say that Tim Berners-Lee was the inventor of the internet, and I totally agree. There's probably a lot of people making the internet possible. But he kind of, I guess he gave us the starting ideas to kind of move in that direction.
On the web, yes.
On the web.
Web, not internet.
Yes. So on the web, not the internet. Cool. Hello, world. So you're using Signal R for sending system notifications to the user. Any thoughts? I think that using one of those frameworks is actually pretty good because you don't have to worry about the implementation. But I guess if you want to take more control and kind of move away from using all those frameworks, which there are some arguments for doing that, for example, sustainability, where if you have less code running, you kind of spend less power doing stuff. And if you know that your infrastructure can take HTTP2, for example, there's no reason for switching to EventSource when you only send data one way. And I have to go next. There we go. So we did that one. Hello, NDC. Is EventSource a standard of the web or an emergent property of web technologies? I'm not sure if I understand what an emergent property of web technologies means, but EventSource is it's the JavaScript interface that we have in the browser to parse this way of sending an event stream. And it's very standard in the browser, so all the browsers have support for this, even the most obscure ones. And I think I looked at caniuse.com before this, and there was nothing holding you back from using this. It's very well supported. So yeah, it's good. How can WebSockets be used in a distributed system? Oh my God, you're really putting me on the spot. WebSockets, when it comes to distribution, is, I think, a subject for a whole different talk by itself, because you can host it on different servers, and you can have proxies in front and kind of make sure the handshaking works perfectly to kind of move you over. But there's a lot of gotchas, I think, that you need to think about. And other... I also think that authentication at that point becomes something you should make sure that you have. And there are probably a lot of companies that have good solutions for this, but I think I don't have the details for it. But it's possible, but it's tedious because you have to keep those connections open and you have to distribute them out and make sure that you don't do everything from the same servers. Good. Can you do normal HTTP requests and the whole EventSource connection is open for you? Two-way communication, yes. And that is very interesting, actually, because back in HTTP 1.1, whenever you did that, you would open another TCP connection with its own separate HTTP flow. But in HTTP 2, what happens under the hood is that it will actually reuse the connection for you completely automatically, which makes it very efficient and has actually led to some people saying that HTTP 2 could be kind of the killer of the WebSocket. And I'm not sure if that's going to happen because the WebSocket gives you so much flexibility in defining your own protocol. But when it comes to efficiency, HTTP HTTP2 gives you this multiplexed connection that lets you send data up and down, so it makes it very efficient. For two-way communication, yes. So the way that you then make the two-way connection is that you open the event stream to get data down, and then you do HTTP requests on the side, normal ones, that you do normal posts, and they will just magically be more efficient. But make sure that you check your network column so that you know it's HTTP2, because if it's 1.1, then it's a whole different story. Okay. Any big differences in stability between WebSockets and SSE? I'm not really sure about that, so I think you're going to have to ask me later, and then I'm going to think about it first. Waterball at Tieto Every stand is using WebSocket, yes. So they use Signal. That was the game I was talking about, by the way, where you control the ball from your phone. So would EventSource enable us to go through a web proxy? Yes, it would. But it also means that you have to make sure that you push the data in separate requests while you have this connection open. And I think actually from your setup, since you push so much data, you push data every time you actually flick your phone, it might be that WebSockets is actually the best way to do it for you. But I would definitely try it out with HTTP2 and kind of push requests often and see if there's a big difference in performance, because that would be very interesting. Good, so are we still good on time? Yeah, I think so. Would you persist data, for example, in your voting app? Yes, so in the Eurovision voting app, the API will persist the data in a database in a normal way. And that's kind of the big pro by not working outside of HTTP. Well, I guess it doesn't really matter. If you use some kind of database that you store data in, you have transactions, and it doesn't matter if you have WebSockets at all, so long as you adhere to your transactions and make sure that everyone else does it as well. Of course, I think it becomes a different topic if you distribute, but then you probably use different services to make sure that distribution works, like Redis or something like that. So yeah, is it possible to use EventSource with Azure native services like Message Bus? I don't really know, actually. I've never used that on Azure. So if someone knows that, we can talk about it later. Have I explored the push API in this context? And the push API, if I get what I think you're getting at, I read some about it, and the push API, I think it was a new feature of HTTP2, and it's meant to push static files to you in the background. And it's not really meant for this sort of streaming of data or real-time communication. So I think it's meant for something else, but it might also be that I misunderstood your question. But, cool, more questions. Have you needed some kind of preventions in your code for avoiding duplicates and similar problems in your voting app? That is such a good question. Thank you for asking that, because I forget everything. So another pro with the EventSource interface in your browser is that you remember the IDs that you saw in the event stream format. You had the ID, you had the event, and you had the data. The ID is supposed to identify that event. And if you send it again, then the browser will actually remember that you have handled this event before, and it will make sure that your listener isn't called again, which gives you, which basically fixes this for you. Exactly for my voting app, it was not a problem because I used it more for timing and getting stuff to happen, so we didn't use that much data that way. We never actually transmitted the voting information. We just pulled that down in normal GET requests. But of course, we could have sent it with the event stream. Okay, so how will HTTP3 change the picture? And about real-time techniques. And that's also a very interesting question, because if we go back to HTTP 1.1, we remember it was it was a bit poor when it comes to event stream. You had the maximum connections of 6 open connections. And then you had HTTP2, which did a lot of stuff under the hood to make it more efficient to use connections. With HTTP3, the major thing that happened there was that we switched out the underlying protocol of everything, because in the network layer, all the previous HTTP versions use something called TCP, which on the network level is you establish a handshake and then you have a connection and then you transfer data. And this all happens below HTTP in the stack. But in HTTP3, at least the proposal is, I'm not really sure where HTTP3 is on distribution or usage yet, but we switched it to be something called QUIP, I think, and someone correct me if it's wrong, but it's a protocol, I think, designed by Google that is based on more of the UDP way of doing it. If you know your network, that means basically that you send information out, but different from TCP is that you don't really care about the data being received. So with TCP, it's a synchronous thing, so I create a connection with you and then I send you data. But with UDP, you throw it out and then you hope someone catches it. And that's kind of the basis of, and I don't know the details about QUIP, but it uses kind of the same idea, I think. And the interesting thing about HTTP3 is that it has something completely new. And I found it. I think I added a picture of it. Didn't I? No, I forgot. Okay. But there's another thing that you can use that's supposed to be even better than WebSockets. And it was, I think it was called Data Flow or something, which is a protocol that you can use on top of HTTP3, which is supposed to be more integrated in your browser and even more stable. So definitely have a look at that. And I think that's it for me today. And I was supposed to say one more thing. Yes, one more thing is thank you all for going down this rabbit hole of real-time technologies with me. I at least think it's super interesting to kind of dive down and figure out how does stuff actually work. And I remember I talked to someone on the show floor yesterday, and they were like, yeah, it's so tedious now when we ship desktop applications, we basically ship a whole browser. And I kind of feel the same, that maybe if we took more care and kind of avoided using so many frameworks, maybe we could be a bit more efficient and everything would be a bit more quick and all that. So yeah, hit me up on Mastodon if you want to point out everything I did wrong, so probably a whole bunch of things. And if you have things to tell me about these technologies. And from there, thank you so much.